All right, y'all, so here we go. Test 8-9 review. So this is time. The one I-
The vending machine, I put my card on there, and it charged me, but it didn't work. It didn't come out.
Oh, I don't know who you on. Ooh, I don't know who you on. Say my time.
I don't know what's wrong with this thing.
Yeah, I really don't. I'll try to find out, guys.
Okay.
I think you had it one day.
Huh?
I think you down there buy it one day.
Yeah.
Taking your money.
It is, I don't know.
All right, so we're just doing the
Wow.
test 8-9 review today. And then Thursday, I'm gonna start reviewing for that final exam.
Okay.
So this review has 15 questions on it, and y'all, the test only has 12 of these on it.
How many?
12 questions.
12 questions?
And it's out of these 15.
Oh,
And some of these are repeats, is why we did that, just to get you good at some of these. So the first examples for number 1. Once we tell whether this is linear or exponential. And then I'll find out what it's going to be worth in 3 years. So they're telling me the value of a house is increasing. So a house is increasing $1,700 per year.
Do we need to, is there some questions that we have to answer, like, for work?
Oh yeah, these will be just like y'all study guide.
You know what I'm saying, like, for like when we go home on the computer?
And it'll be a study guide in there for you. So if you look on there, it should say test 8-9 review in there. Okay? All right, so the house is increasing $1,700 per year. Today, this house is worth $130,000. And then they want to know what it'll be worth in 3 years.
So are you gonna multiply or are you gonna divide?
Oh, we'll do a little bit of that. So first, we want to know if it's linear or exponential.
I think it's,
And remember-
it's not exponential, it's linear.
No, it's linear because it's always the same
Yeah,
amount
it's by
each year.
year, yeah.
So that's gonna be linear. Exponential, remember, does that percent,
Yeah.
like 3%, 5% a year. So it's $1,700 per year for 3 years. So what I did on this, and I just put my $130,000 I started with. And then I'm gonna add what you said, I'm gonna take the 3 years and multiply by what, 1,700 per year? Because that's how much it's going up a year. So y'all, let me get my calculator out to figure that one out.
Oh, so you put in parentheses, that means you multiply, right?
Yeah, you could do it
So
like
the
this.
1,700
Sometimes
times 3 is gonna be 21,000.
So something like that, they do like that.
21,000, and you add 21,000 plus the 130.
So what's that gonna be, 135,000
Yeah.
and 100. Now, the main thing you wanna watch out on these is look at those answer blanks and see how they want these answers. This one came out perfect, but some of these are gonna say round to the nearest cent, round to the nearest dollar, so be careful on those, okay?
So if you round to the nearest 10, would it be 36?
Something like that, like 0.36, point something.
Oh.
All right, same type of question, linear or exponential. This one is the population increases by 622 people a year. And then they say if it's 1,200 today, for 1,200 a day, what would it be in 4 years? Is yours show the same type of questions?
I just pulled it up.
Okay, I just want to make sure yours is going through sort of the same order, I think.
Which one is it? The 15 question
Yeah,
on here?
no, it says 8 and 9 review or something like that, study guide.
This?
Yeah, that's it.
Okay.
Oh, that's the same type of question, because mine was the house increasing by so much on my first one. All right, so once again, it's the same amount every year, so this is once again going to be linear. And I'm going to work it the same way. I'm going to start out with that 1,200. And then I'm going to add 4 years times the 622. And that's what I did right here. I started with my 130,000, and then how many years was I gaining? 1,700. But this one had 4 years at 622. When I multiplied that out, I got 3,688. And just make sure these amounts are going up because it said it was increasing, okay? So that was the trick on those first two being linear. Take how many years you're looking at, multiply by how many it's increasing a year, then add them together and be done, okay?
Okay.
So now let's play with these with the percents on them.
So the final damn tell me over everything we covered.
And I'm gonna start reviewing that Thursday. So Thursday and then probably Tuesday, I'll finish that final exam review. And we'll try to, I'll go over all of them because the study guide I think was about 45, 50 questions on it. But I'm gonna sort of narrow down the ones you really wanna focus on, if you know what I mean.
Okay.
Because the final exam's only, I think it's like 25 or 30 questions and all.
All right.
So a lot of them questions are just repeats and stuff. Some are longer. If you get into that stat stuff we was doing with the standard deviation and stuff, some of them problems were a little longer. So yeah, so they. All right, this one says during the worst periods of hyperinflation in a certain country, the price of food increased at a rate of 30% per month. So it increased 30% per month. They want to know if this is linear or exponential.
It's gonna be exponential.
Definitely. And then they say if your food bill was $90, if food bill was $90, what would it be 3 months later? So you were right, that is definitely exponential because now you're looking at percents per month. So anytime you see them percents, y'all just remember exponential. So I worked these ones a little different because each year, if you're adding 30%, you're going to start with different amounts each year, okay? So what I did on this one, I'm going to start with $90. And for the first month, now remember, you can't multiply by 30%, so you got to turn that into a decimal. So you move the decimal left twice, so that'll be a 0.30 times what you started with, which was the $90. So notice the difference. You start with $90, and then you're going to add 30% of that $90 to it, okay? That gave me 117 for that first month.
I have a question. Why wouldn't you multiply it by the 3 months?
Oh, because if you multiply it by 3 months right off the bat, then you're only taking 30% of that same amount.
Okay.
So look at this, after 1 month, when I increase it by 30%, after 1 month, my total is now 117. So for my second month, I'm gonna start with that 117, and then I'm gonna add 30% of the 117 to this to get my new amount. Then I'll take that total and do it for my last month and figure out what that's gonna give me, okay? So 30% of 117 added to 117 gave me a 152.1 at that point. Okay? So take your starting amount, okay? Take your starting amount, figure out 30% of it, add them together. Take that new amount, figure out what 30% of it is, add them together. Then we're going to take this 152.1, add 30% of it, so that gave me 197.73. This one says round to the nearest dollar.
So it'll be 198.
198. Now just remember, since this said increases, when you're done, you gotta have more money than you started with. So I think we're going to do this right now, right? Because our food bills are going up every month.
Yeah.
I know we went to the store the other day and something that usually costs us probably $75 total is like 100 and something now. Everything's going up. So that's what they're talking about, hyperinflation. That kind of stuff is going up, okay? So I'm gonna do the same type problem, except this time I'm gonna do it decreasing.
So you increase, you want multiplying or adding.
Mhm.
For decrease, it's subtracting or dividing.
I'm gonna be, same thing, except we're gonna be, like you say, subtracting. So on decrease, we'll subtract that 30% or 40% each month and see what we get. So this one, the price of a computer is decreasing at 11% per year. Is this linear or exponential?
Exponential.
So it is definitely exponential again, because you got that percent. If it costs 80 today, what will it cost in 3 years?
I have a question.
Mhm.
Are you coming for a sec?
Mhm.
Okay, so we had a little different one than you. So I'm trying to see that I do this right, because ours was 100 and it was 10%.
Mm-hmm. So give
Can I do that right?
Yeah, the only thing is take off that decimal because it wants you to round it to the nearest dollar. So that'd be just 132. They don't want no decimals on that. So just hit enter now. Oh, you can't get one.
Yes.
So you just take away that decimal on that. But you're doing it right. You just want to keep adding them and then you start
Okay,
the new
because
amount.
yours was, because you had got a decimal on this one, so I thought maybe I did it wrong. So you
Oh,
had
no, no,
152.
because yours just come out. Because, yeah, 10% of 100 was 10, and then 10% of that's 11, which is 121. 10% of that is 12, 10 or something. So, yeah.
Okay.
You just gotta watch them how they want them final answers.
Okay.
So I'm gonna do the same thing, except for instead of adding, we're gonna, like you said, subtract it. So I'm starting with $80. I'm gonna subtract 11%, which is 0.11, because we gotta move that decimal, times that 80. That gave me 71.2. So it decreased, like we said, it decreased by almost 10%, right? 11 is 10% almost, so that's $8 off of that, pretty close. Then you're gonna start with 71.2 and subtract 11% of it. So that one, I got even crazier, but I usually keep all my decimals, Kathy, till I get to the end, and then I start rounding them. When I did this one, I got a big decimal, 63.368. So basically, it started at 80, went to 71 on 1 year. From 71, it went to 63 on the second year. So then I start with the 63.368, and I'm going to figure out 11% of that. I want y'all to notice this. Each row, what you start with is the same amount you're taking that 11% off of.
Okay.
Here you started with 71, you're taking 11% of it off. Here you started with 63, you're taking off 11% of that. Well, let me see, which one am I doing? Okay, so I came up with 56.39752. This one wants me to round to the nearest cents. So the nearest cents would be right there.
40.
Okay, 56.40.
56.40.
Oh, you're good. So that 9 rounds up to a 0, which means it has to round that 3 up to a 4. So good job. You like to round them good. That'd actually be what, dollars? Make sure it went down from 80 when you're done, okay? If you went up, then you actually probably added them instead of subtracting them. And the main words I was looking at that tell me to add or subtract was increase and that decrease on that, okay? One more of these, and then we get into a little bit of graph and all. Graph is not too bad. All right, number 5. Linear or exponential. The value of a house is increasing by $2,500 a year.
Linear.
Bam, it's linear for sure. If it's worth $180,000 today, what will it be worth in 4 years? So this one, like we did a while ago, we can just start with our starting amount, which was 180,000, and how much it's increasing. And we said it was what, 4 years? Times what I have, 2,500 a year. Well, let's see, 4 times 2,500 is pretty much 1,000. So that's just, 10,000. So that's going to be 190,000. So after 4 years, this house went from 180,000 to 190,000. And then we said that was linear, okay? So 3 of those were linear, 2 of those were exponential. Linear ones, you just figure out if it's increasing, you add the amount times the years. Decreasing, I would subtract the amount times the years. Exponential, you sort of got to work it in steps by the years or the months, okay? All right, 6, I'm going to have to draw an X and Y axis here, but it wants me to graph. A will be 4, 3. B will be -8, 1. C is 0, -2. And then D will be -2, 1. Now, y'all just want to pick out a picture on that one, but I'm actually going to graph them out.
This one is cents, so it'll be 50.23%.
Round to the nearest cents, so do like you did, 50.22. So you're good to go. Oh, my neck, my neck. Go back. Once it's still. There, 50. Oh, go back. 0. 0.22. Right, it was it.
Well, no, this was the answer. But it wants cents, so the figure like
Well,
that.
22 cents is the cents.
Okay, the figure like that. Okay.
So anytime they're saying round to the nearest dollars on those, you don't want anything after the decimal.
Mhm.
If they say round to the nearest cents, you want 2 numbers after the decimal.
Okay.
All right, so I want to draw this as an X and Y graph. So let me pull this up. I'm gonna try to make it big enough to do. I guess I need to go out about 10, right, with these numbers. So there's 5, 10, -5. So 4, 3. Now, remember, when both these numbers are positive, it's going to be in this first section. But everything's positive. X's are positive and the Y's are positive. So 4, 3, you would go right 4 and then up 3. 1, 2, 3. So first number tells me left or right. Second number tells me up or down, okay? And I'll tell you a trick. Once you plot A, they've got it in 4 different sections. There's only one right answer after that, you know? -8, 1. Go -8 to the left, and then up 1. So that would be my B. Zero, -2. Anytime the first number is a 0, you're going to stay right on that line.
You wanna go over 2, right?
Well, instead of going over 2, you're going to go
Down 2.
down 2.
Because it's negative.
That'd be your C. So remember, these points are like an X and a Y.
Right.
If the X is positive, it moves right. If it's negative, it moves left. If the Y is positive, it moves up. If it's negative, it'll move down. Okay, so that's how your points can either go left or right, and then up or down, okay? So D is a -2, 1. So -2 on the X tells me to go left 2. I'll go left 2, and then the 1 being positive for the Y wants me to go up 1, and there would be my D. So yours is sure to be similar, but figure out what the A is, because A is only right on one of these. So where would 5, 3 be? Yeah, you're good. So pick it. Because see, it's the only one that's got A in the right spot. The other's got it all over. Okay. So usually, as long as you can plot that A, since it's in 4 different spots, you're good to go on that. And then you'll notice all the other points will be where they need to be. Okay. All right, for 7, you sort of have to figure out which one's the independent, which one's the dependent. So they want to know which one's the independent and dependent. So let me write down what I'm going to do. So independent variable and my dependent. Remember, the independent can change and be whatever. The dependent depends on what that change was. So you're taking a road trip in a car and want to know how far you've traveled at various times during your trip. So I figured on that one, the independent variable would be the time, because you can travel for any time you want to, right? So time would be your independent variable. Your dependent variable would be how far do you travel? So that'd be what, your distance? So they'll sort of hit you with stuff like that. Yours similar to that on 7?
Mm-hmm.
So it's the same
It's
kind
the
of way?
same thing, yeah.
So some of those here, they couldn't change up very good. Yeah. Cause see, the one you can control is time. Am I going to drive for an hour? Am I going to drive for 2 hours and stuff?
Mhm.
And then based on that time, if you're going at certain rates, then you can figure out 70 miles an hour, how far I went in those hours or 2 or whatever, okay? All right, same thing. I'm going to name out 4 answers, and they want us to pick the one that is possible function between these two. So weigh a bag of oranges. And the price of the bag of oranges. So what they want you to figure is this. If the weight of the bag of oranges goes up, do you think the price of the oranges is going to go up or down?
So the way would be the independent, wouldn't it? Would the way be the independent?
Independent and
And the
independent.
dependent would be
Dependent.
the variable.
Now, what they want to know though is this. What kind of relationship could they possibly have? As the price of the bag decreases, the weight increases. Well, that don't make sense. The less you pay for the oranges, you're not going to get more oranges, right? As the weight of the bag of oranges decreases, the price increases. Well, that don't make sense. You're getting less oranges for more money, right? As the weight of the bag increases, the price of the bag increases.
I think it's the last one.
Bam, there you go. As the weight increases, then we're thinking that the price will increase also. So they just want to see that you sort of understand how that dependent and independent sort of work together, okay?
Okay.
So they both increase.
Yeah, in our world, right? I ain't never bought more than something and got it for less. Okay, so we're the same thing. We're going to find a possible function, same thing we did here. This time we got number of trucks on the road. And air quality. So if I was looking at independent, dependent, independent variable would be how many trucks are on the road. The dependent variable would be the air quality. But here's what I want to know. Do you expect these trucks, as they increase the number of trucks on the road, do you think the air quality will increase or decrease?
You say that again?
If I increase the number of trucks on the road, do we expect the air quality to get better or get worse? More exhaust means worse air quality, right?
Yeah.
The more trucks you get, one little truck going down the road, he's spewing out a little exhaust, he's not hurting much. 100 trucks on the road, 1,000 trucks on that road. All these mufflers are going to make that air quality go down. So this one I went with as trucks increase,
I don't get it now because the air quality depends on the number of trucks on the road.
mhm,
That's right.
and then the air quality decreases. So what they wanted y'all to see, this one, as my bag of oranges got heavier, the price went up. So it was a positive effect. Everything was going up. This one, the air quality would be a negative effect because it would be going down as you got more trucks on the road, okay? Well, I'm gonna try to draw this next one, y'all, just to give you an idea. So that's 75, 80, 85, 90, 95, 2000, and then 2005. So these are years, 1980, 1985, and so on.
Well, the only one I see like that is this one.
Oh yeah, this one I just did over there, my number 9 up there. So do you expect as you get more trucks on the road, what's going to happen to that air quality? The air quality going to get worse, ain't it? Because the more trucks, the more pollution. So, well, as they decrease, it deteriorates. That don't make sense. And I mean, air quality ain't the independent variable. What if this one, the number of SUVs on the roads increases, then the air quality is going to be more polluted, which makes it decrease or deteriorates. Okay. All right, you see my y-axis, I got 0, 20, 40, 60, 70, and then one more up to 80. So let me draw these little lines I got. This one's about right here. Hold on, let me a little better. 85 was right here. 90 was right here. 95 went up a little higher. And then this last one went up like that. And it's giving you a graph sort of like that. And then it's got some answers on the right. So you want to pick the best answer for this one that sort of describes, and I went with the function shows. So the function shows a steadily increasing average age of death between 1980 and 2004. Okay, so they started at 80 and then they're stopping over here about 2004. But this graph is going uphill, so it's definitely increasing. To have no change, it would have to be a straight line going across. Because remember, this is the years and this is the number of deaths. So it's definitely going uphill left and right. So let me see what you got on yours.
I think mine's like the first one.
Yeah, same thing. And it's going uphill, so the decrease, the only way you can get that is if it was going down. Okay. Oh no, y'all, I sent out an email today to get bonus for this test. I want to give y'all bonus points on this one. To get bonus points on this test, you have to make a 70 on that review y'all were doing. So the test 8-9 review, if you make a 70 or better, I'm gonna give you 5 points on your test. That's half of that grade, girl. That'll turn that 85 into a 9.
Okay.
You know what I mean? So there you go.
I understand.
And you gotta do it anyway, so.
All right.
Make
Right, what she
it
paid for.
So in math, what's the purpose of a function? And it's pretty much what we've been doing. A function describes how one variable depends on another. So it describes how one variable depends on another. Now they're going to give you some wild answers about operations and multiplying and division. Those are types of functions, but that's not exactly what a function is. Okay, a function relates to that independent variable and that dependent variable. Okay, and they got one of these. A function describes how inputs and outputs are affected by machines. They got some crazy answers.
Like that little thing you did last week when you like that, the little origin on the clock thing. Isn't that the input and output?
That's one type of function. The X's are your inputs and the Y's are your outputs. And they're usually related. Those were linear equations, so those ones usually come out as a line when we was doing them. All right, then you get to some more of this linear stuff. So they say the cost of renting a car has a flat rate of $25 plus 0.2 cents per mile. How far can you drive for $90? So the first thing they did, they wanted me to come up with the equation that I would use to figure that out. So the rental, so they call it R, which is the rental fee. So sometimes they'll use letters to describe sort of what they're using them for. So on this one, R means the rental fee. So let's write that out, rental fee. It's going to equal the flat rate of $25 because you got to pay that no matter what. Plus 0.2 cents, 0.2 times how many miles I went, right?
90.
So I'm just going to write my general formula. So I'm going to use M for my miles. So the first step, they just want you to write the equation you're going to use. Oh, I see we got 90, but that's not my miles, that's my dollars.
All right, so how did,
So this one is
so
going
what
to
you
be,
trying, so you're trying to find the mile?
yeah, I'm trying to find the miles. Now,
Okay, so you're
usually-
not trying to find how much.
So usually they would say, hey, if you go 50 miles, this is how you get your cost, right?
Okay.
But they're not giving me the miles, they're giving me the R this time. R is the rental fee. So to see how far I could do for $90, I would do it like this. 90 equals 25
I get it now.
plus 0.2 times your miles.
Okay, gotcha.
We're going to solve that for the M. So y'all, to solve this for the M, we're first going to subtract 25 from both sides.
Okay, and then
So what's that? 90 minus 25, 65.
six, is it six? Yeah.
Now, all that's left over here is the 0.2 M.
And I'm divide that.
Yeah,
I'm
divide.
both sides by 2, by
Mhm,
0.2.
Because anytime you multiply, you're gonna undo that by dividing. So take the 65, divide by the 0.2.
It's gonna be, I think 32.1.
I don't know if you're doing that in your head, you're doing pretty good. Oh, you're close, but it's in hundreds because of that decimal is what's getting you. So I came up with 325.
Also.
But you were doing right, you had the numbers right, pretty close.
Right.
It's just this decimal is getting you. So you can go for $90, 325 miles. That's how they make their money, y'all. Like phone companies. This phone company, Apple might say, hey, you can have my phone for $40 a month and we'll only charge you so much for over usages or something. Another phone might be $35 a month, but they might have higher price for the overages and stuff. So you gotta weigh them out in the long run, you know, who's got the better plan if I use it a lot. If I don't use it a lot, I'm gonna go with the cheaper one. But if I use it a whole lot, and they're not as high on that part of it, then it might work out better doing that plan, you know, so.
Yeah.
That's what you gotta figure out long terms and some of those things, you know. All right, so let me show you what I did on 13. 13, they give you a graph, but I didn't even worry about the graph. I just figured out what the amounts would be, and only one of them graphs had the right amounts. So during the month of January, the depth of snow at a ski resort decreases by 2 inches a day. So it decreases 2 inches a day. On December 31st, so December 31st, there was 64 inches of snow. So we're going to find the equation that represents this linear function and estimate the snow on January 28th. So how much snow January 28th? Well, so what you had to do really, you know you're starting with 64 inches. And this is going to sort of be like my very first questions on the linear exponential, because it's decreasing the same amount a day, right? So it's decreasing by 2 inches a day times, what y'all got to figure out is what is how many days from January 28th from December 31st. And that was 28 days, right?
Okay.
So you multiply 2 inches times the 28 days.
That's 56.
And what's 64 minus 56?
56.
64 minus that 56.
18.
Oh, you're so close. How about?
Is it 18? I think it's 18. Is it 8?
Mm-hmm.
Oh my God.
Oh, yeah, you can
yeah,
you can turn that down. There you go. So if they had 64 inches December 31st, January 28th, they would have 8 inches of snow.
So on number 12, the keyword was plus. But we should subtract it though.
So
But
plus,
on this one, it said decrease, but we subtract it.
so
So
you
what is
subtract it. So you're looking at the keywords. Increase, decrease, plus, minus. Anything that might mean take away, you know, deteriorates at a rate of blah, blah, blah. That's the trick on these phones, right? That tells you the main operation. Am I adding stuff or am I
That's
subtracting?
what I'm looking. I'm trying to figure that out.
Well, you're doing good on them. Confidence, you got that confidence sometimes. So you're still following me on the same type of problem, Frank?
Mm-hmm.
All right, so I'm on 14. You want to write an equation and then figure out what they want.
So is the writing equation part of the problem too? Like we have to write the equation and then solve the equation?
Well, that one, they didn't have you didn't have to actually show them the equation. All they was wanting on that one was the amount, and then it showed 4 graphs. It'll show you like 4 graphs. But the only one right's the one that has the 8 inches on it.
Okay.
And then you can see they're all going down here anyway, so. I think on this one, the main thing was just coming up with this to get that answer. All right, so Normaltown High School pool record for the 100-yard freestyle was 46.70. So 46.70 is the record in 1990. Assume that the record falls at a constant rate of 0.05 seconds a year. So if it falls at a constant rate, that would be decreasing. So 0.5 seconds per year, it decreases. So look for them kind of words also, falling and rising and stuff, okay? They want to know, what does the model predict for 2013? So on this one, I took the 4670 that I started with. Am I going to add or subtract?
Subtract.
I'm going to subtract, because you're right, falling and decreasing means subtracting. So how many years is that? From 2013 to 1990?
Wow, I think it's 40.
You
No,
said 40?
I did it wrong. I did it wrong.
Well, no, this is 13 from 2000, and then from 90 to 2000 would be 10. So that'd be 23, right? Subtract that calculator. 2013 minus 1990. 23. So 23 years at, how much did it fall a year?
And on top of the 0 point.
Well, you do 23 years.
Because I had to figure out the number of years between 2013 and 1990, and that gave me 23 years. So see what your ending year is and what you're starting at on yours.
Mine
So yours is 2023. So yours is going to be 10 years bigger than mine, and mine stopped at 2013.
so I need to do.
So yours will be, what, 33 here? And then what was your percent? The same percent, 0.05?
No, it was 0.04.
So see, you're going to do it the same way, but all your numbers will be a little different than mine. Now, it's falling, so they better be getting done faster, right? So mine came up with, so this one I actually had to figure out the equation. So the equation would be R, would be the 4670 minus 0.05 times T, which is my years. So basically what we got here, they just wanted it officially wrote out.
Yeah.
If you work that, I got 45.55. Now they got some that are like 1,000. Those went up. You don't want to go up if you're breaking a record every other year, right? You're getting quicker and quicker. So if it was 46, anything over 46 ain't right. So throw them 2 answers out, and it's got to be one of those that are more close, okay?
So the 45.55 is T, right?
would be,
Would it be T? I mean, that's the answer, but would it be?
oh, it's actually, when you saw this, you're finding the R. Now, because we wanted to see what was the record. R was the record on this one. T was your time in years, which was the 23. Okay. It's just because that one while ago was backwards we were doing
Yeah.
with the car. They didn't give you the miles, they gave you the ending amount they paid on it. So just watching when they want to switch that up on you too.
I keep getting so confused.
Sometimes you solve for the actual R, and sometimes you got to solve for, only one of them though you had to solve for the one with the rental car is the only one that has to sort
Yeah.
backwards. Okay. Oh, I got one more to go. Now, nobody should miss this last one.
No, I can hear it.
What are the 3 basic ways to represent a function?
Ooh.
It should be,
Is it graph?
Graph is definitely one because we've been graphing for a while.
Okay, graph, wow. That's all the way out. Equation.
Equation, you got 2 of them, come on.
Okay, and, I don't know why.
table.
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 Like that's my favorite, you asked me that one ago.
Do we do like
You
that?
said that one ago,
Okay.
remember? You said, what about
The
the,
input, output, okay, yeah.
so everybody should get that because they can't change their math. That's always gonna be graph, equation, table on that, okay?
Trying to trick us.
Hey, so this math is getting into that head, ain't it? So y'all, that is your 8 and 9 test. So do that little study guide like we just did. That's 5 extra points for the test.
So when you take the test, it's 5 points added to whatever grade you make?
So if you made a 95 on the test, when you do that, make a 70, you're gonna get 100 on your test. Now here's what's nice about this. This test is fairly easy. Other than you got the 2 problems that are a little trickier when you have to do the exponential stuff
Yeah.
with the percents. But say you made it a little lower on your first test than you wanted. This test, you do really good, you could possibly get up to 105 on this test. That'll pull any low test up big time,
Right, right.
okay? And all y'all are doing decent in here anyway, so this will just
Make it up.
shoot it on up more. Okay, so questions online. Y'all good?
I'm good.
All righty, I will see you Thursday for my final exam review. I'm gonna,
So when is our final exam this class? Thursday?
what now?
Our final exam this class is Thursday? Next Thursday?
Oh, come this Thursday.
Is this Thursday?
I'm
What
gonna,
about the final exam, the actual?
oh, the final, okay, so here's the deal. Final exam opens next Wednesday.
Next two, next one.
So I'll finish y'all reviewing Tuesday, because this is 50. I don't think I can do all 50 of them in one class Thursday. So whatever's left, we'll finish Tuesday. That'll be your final exam study guide, right? Then that'll be May 5th. Is that Wednesday, I think? I'm gonna open up that final exam. Now, I was gonna make it do that Friday, but I extended it till the Sunday night. Everything in this class has to be done by May 9th.
Okay.
If you got any homework that needs caught up, anything, you gotta get them done because after May 9th, y'all won't get access no more. Okay? And,
Okay.
and y'all are doing good enough, so we just gotta get you on through this class. Okay, and then I can move on to nursing.
I don't think I rounded things good, but anyway, I mean, it's good.
Oh, that's only one, so let me see, go back to it. If it's round off there, I'm gonna give you that point. You want that bonus, ain't you? You got your bonus, there. You got 95 on yours.
Mm-hmm.
Meow, meow.
Hold on,
I was thinking, I think you just restarted it. Go to review. Go to the review on that. Let me see. No, what is your grade book? Go back to that.
It's-
Let's see, these next thing review, so go back to your grade book thing. On that page, you were just asking, go back. And you know, the grade book. And then which one was that? So, pull down which one it was. Let me pull it up on mine. If you're within a penny or two, I'm gonna give it to you. Let me see.
My answer was 132, was 132.
So they probably wanted it rounded and
Yeah.
in the nearest dollars.